So this is an example for section 10.2 on page 491, number 26. So it says that in the American Animal Hospital Association survey, it says that 37% of respondents stated that they talked to their pets on the telephone. A veterinarian found this result hard to believe, so he randomly selected 150 pet owners and discovered that 54 of them spoke to their pets on the telephone. Does the veterinarian have the right to be skeptical? Use a 0.05 level of significance. Okay, so, all right, so we had 37% of people that talk to their pets on the phone. Okay, so since that's a percentage, it's a proportion of the American population. Okay, so what is that, what is the variable that we assign to that? That's our population proportion, P, right? Okay, so we're going to write that as 0.37. Okay, so that's my null hypothesis, is that my population proportion is equal to 0.37. Okay, then what would my alternative hypothesis be? It's going to be the same parameter and the same number, but what's going to go in the middle there? It says he found this result hard to believe.
So not equal.
Not equal. So it just says, does he have the right to be skeptical? So that's going to be a not equal. All right. So then it says that he randomly selected 150 pet owners. So what is that 150? N, his sample size, lowercase n. Okay, and it says that he discovered 54 of them spoke to their pet on the telephone. So what is that? Your X, your number that have the characteristic that you're looking for. Okay, so what is P hat then?
N divided by X.
54, it's X over N. X over N, which is 54 divided by 150. And if you put that in your calculator, 0.36. Okay? All right, so that's your P hat. So remember, we have to see if our three assumptions are true. So first of all, is it a simple random sample? Well, it says he randomly selected 150 pet owners. So that's all you need is that wording. Okay, then it says, so we could say that it is a simple random sample. Okay, we can also look at N times P times 1 minus P, see if that's greater than or equal to 10 to tell whether it's normally distributed or not. So what is N? 150 times P, and again, these are the P naughts, the originals. 0.37, and then 1 minus 0.37, 0.63. So what does that equal? If you put that in your calculator, it should be 34.965. Is that right? So that's greater than 10. So check. That means that it's normal. Okay. And then the third thing is our sample size less than or equal to 5% or 0.05 of our population size. So do you think 150 is less than 5% of all pet owners? Yes, because there are millions of pet owners in the U.S., right? Okay, so we can say that it is independent, because this is huge, right? The number in the population. So that means that it's independent, that the samples are independent. Okay, so then we can go ahead with our test. So we'll find our test statistic. So Z naught is going to be P hat minus P naught over the square root of P naught minus, or times 1 minus P naught divided by N. Okay, so for this particular problem, that's going to be 0.36 for the P hat that we found here, minus the P naught, the original population proportion is 0.37, divided by the original population proportion, or the square root of the original population proportion, 0.37, times 1 minus 0.37 is 0.63, divided by N is 150. Okay, so put that in your calculator. And when you put this in your calculator, make sure that you put parentheses around the entire numerator, then divided by square root of, and then parentheses around the entire denominator. Okay, so you can put in 0.37 times 0.63, and you don't need that parentheses if you just do times, and then divided by 150, and then close the parentheses at the end of the square root. So what does that give us? Should be something like negative 0.25. Okay. So
negative 0.2536.
2536. Okay. All right. So that's going to be your test statistic. Okay. So if we want to use the classical approach, then we would take that Z value and put it on, or we would take our alpha and put it on the normal curve. Okay, so what is our alpha? I don't think I wrote it down, but it was given to us. It says use a 0.05 level of significance. Okay, so I'm just going to write that back up here at the beginning. Alpha is 0.05. Okay, and because our alternative hypothesis is not equal to, that means that that alpha is split between these two tails. Okay, because this is not equal to. If it was greater than, then it would all be in the right tail. If it was less than, it would all be in the left tail. Okay, so if I take that 0.05 and divide it in half, that means 0.025, which is alpha over 2 in this tail, and 0.025 in the left tail. Okay? All right, so then we need to find these z-scores that correspond to that. Okay, so you can put in your calculator for this one, the area to the left is 0.025. So you do second distribution, inverse norm, and then you put the area to the left is 0.025. And since we're looking for a z, this is the negative z alpha over 2, and this is the positive z alpha over 2. Okay? So the mean is 0 and the standard deviation is 1. So what is it?
Negative 0.04899. Oh.
Should be negative 1.96.
That's what I got.
maybe, yeah, the area to the left is positive 0.025 because it's a positive area. Okay, and then because this is symmetric, then what is the positive Z alpha over 2? 1.96. Okay. All right, so I calculated my test statistic here. My test statistic is negative 0.2536. So put that on the same normal curve, and where does it fall? Negative is to the left of the mean, and 0.25 is not as far as this. This is almost 2 standard deviations to the left. So Z naught is negative 0.25 is right here. So does it fall in the rejection region or not? Not. So since Z naught is not in the rejection region, we fail to reject the null hypothesis. Okay? So that's using the classical approach. So let's do the same problem using the p-value method. Okay, so the p-value method, you're going to take a normal curve and you're going to put your z on it. Okay, so the mean is here. My test statistic, z was negative 0.2536. So I'm going to put that on the normal curve. So somewhere right here, maybe. Okay, so z equals negative 0.2536. Okay, so since this is a two-tailed test, I'm going to find the area to the left here. And then, because it's a two-tailed test, I have to do the area on the right also. Okay, so if I put in my calculator to find this area, you can either look up in on your table, z is negative 0.25, and find this area. So if you look that up on the table, this is going to be kind of hard to see. It's kind of dark. But z, you're going to go down the left column. Z is negative 0.25, so negative 0.2, and then go across the top to 0.05, and then where that column meets the negative 0.2, 0.4013. So that means the area to the left of my test statistic, 0.2536, is 0.4013. And then, because my alternative hypothesis was not equal to, that means it's a two-tailed test. So I also have to find on this, using symmetry, the positive z 0.2536. So because of symmetry, that's going to be the same area on the right side. Okay? So the p-value is going to be those two areas added together. Okay, so the p-value, you can either think of it as this area here is the probability that z is less than negative 0.25, And you can think of it as that times 2 because it's symmetric. So you can just do that times 2, or you can write it as probability z is less than negative 0.25 plus the probability z is greater than 0.25. All right. So that's going to be 2 times 0.4013, which is 0.8026, right? So that's my p-value. Then you compare the p-value to the alpha. And what was the alpha? 0.05. And the p-value is 0.8026. So which one's bigger? P-value. So if the p is high, the null must fly. So that means we fail to reject the null hypothesis. Okay? So you should get the same result whether you use the classical approach or the p-value approach. So it's kind of a good double check for you. And when you do your project, I want you to show both. Okay? All right, so then the last thing you need to do is write a conclusion. Okay, so the conclusion, it said, in the question, it said, does the veterinarian have the right to be skeptical? Okay, so we failed to reject the null hypothesis there, right? So we failed to reject this, meaning that no, he didn't have the right to be skeptical. Okay, so the conclusion is you could say we do not, or the veterinarian, you could say the veterinarian did not have sufficient evidence So the veterinarian did not have sufficient evidence to show that the proportion of dog owners or pet owners, not just dog, pet owners that talk to their pet on the phone is different. So he didn't have enough evidence to say that that proportion is different or not equal to 37% or 0.37. Okay. So then in section 10.3, you're going to do the same thing, but you're doing it for the mean, for calculating the mean. Okay? So when you calculate the mean, the difference is your test statistic. Okay? So remember, the test statistic when you're calculating the mean is the test statistic for calculating the mean is T naught equals X bar minus mu naught, the original mean that is given to you, divided by S divided by the square root of N. So this is the test statistic to test the population mean. Okay? Otherwise, you do the test the same way. The difference is only in the test statistic. Okay? And also, when you look up your values on the t-table, you use the t-table instead of the z-table. Okay, one more thing, let me show you on your calculator how you can do these tests. Okay, so for a P to test your population proportion, you're going to go to, let me grab the calculator so you can see it. Okay, so you're going to go to Stat, and then to Tests, and then go down to 1 prop Z test. Okay, so Stat, Tests, 1 prop, so 1 proportion Z test. Okay, press enter, and then you're going to put in P naught, which is the original population proportion that you're given. You're going to put in X, which is the number that have the characteristic that you want. You're going to put in the N, which is the number in your sample, and then you're going to choose prop not equal to P naught, less than P naught, or greater than P naught, and that's based on your alternative hypothesis. Okay, so depending on what your alternative hypothesis says, if it's less than, you're going to click on less than. If it's greater than, you're going to put greater than. If it's not equal, you'll put not equal.
Could you go into that again, because I don't see the P option on the
One. So you go to Stat, Tests, and then go down to 1 prop Z test, and then you'll put in your original P, your X value, the number that have the characteristic that you want, the N, the number in your sample, and then choose which the form that your alternative hypothesis has. And then you'll click on calculate, and this is what it gives you. Okay, it gives you the Z, which is the test statistic that we calculated using the formula. It gives you the P, which is, this is the P value, so don't get confused. This is not the P naught. It's not the original P value. It's not the original population proportion. It's the P value, and then the P hat is the 0.57, and the N is the 500. So this will calculate for you, but it doesn't tell you how to use it. So you need to be able to follow what we were doing for the classical approach and the p-value method. Okay? Then when you're calculating, when you're testing the hypothesis of a mean, of a population mean, you're going to go to Stat Tests again. So when you're calculating for the mean, you're going to go to Stat, Tests, and then this time you're going to choose T-test. Okay, so you're going to select number 2 is T-test. Okay, so if you look on here, you go Stat, Tests, then go down to number 2, T-test. Okay, then it gives you the option of choosing data or stats. So if you had a list of raw data that you put into your calculator, you would choose data, and it'll calculate everything for you. If you didn't get a list of raw data, then you choose stats, and then you have to put in the original population mean. You have to put in the sample mean that you calculate from the sample that you drew or that was given to you, the sample standard deviation, the sample size, and then choose the form of your alternative hypothesis, which is going to be not equal to, less than, or greater than, and then calculate.
That's for calculating the mu?
Yes, for the test for mu, yes. Okay, so that's going to give you the T value, which is your test statistic. It's going to give you the P value, okay, which is what you're going to compare to the alpha for the p-value method. It's going to give you the x bar and the sample standard deviation. So the x bar is the sample mean, and the sample standard deviation, and then the sample size. Okay, so it gives you everything you need to run the test.